guys, welcome back to my new video. In today's video, I'll show reverse level order traversal. Now go to understand this problem, and first we need to understand level order traversal. What is level order traversal? Level order traversal means we traverse all of nodes level by level, and in this binary, this is root node. Okay, this is level 0 or level 1, what you have suppose, and this node is level 1 and this is level 2. Okay, in level order traversal we traverse all of nodes level by level, means top to down approach. Okay, top to down. Now first we will print root node 1, then we print all of nodes in level 1, 2 and 3. We'll print 2 3, then in level 2 all of node 4 and 5. Okay, and in reverse level order traversal we will move traverse all of node in bottom to top. Okay, bottom to top approach, bottom to top, and it will print like this last level 4 5, and next level 2 1 all of nodes, 2 3 all of nodes, and next go to upper level 1, like this is reverse. Okay, now in reverse level order traversal, we will use two data structures, stack and queue. In queue, it always with the nodes who will come first, we will remove that first. Okay, and in stack, the nodes who will come last, it will remove from first. Okay, now understand. In this binary, first root node is 1. Okay, we'll write root node 1, then it will go to queue. Now check queue is full or not. Now queue is full, so we'll push it to stack. Okay, push it to stack. Now we'll remove from queue 1, go to stack. This one go to stack. Now check if root 1 have any children or not. Yes, there are two children, 2 and 3. Now it will go to into queue. You must remember we will move traverse it from right to left. Okay, right to left. So first 3 will come, then 2. Okay, then 2, and now queue is full. So now first root will be 3, and 3 will go to stack. We remove from queue and it will go to stack, and check 3 have any children, no, so we no need to enter any nodes of roots, nodes key 3 into queue. Now go to next node. Now root is 2. Okay, remove from the, now root is 2. Now queue is full, so it will push it to stack. Push it to stack, then it will go to stack. Now check to have any children. Yes, to have two children, 4 and 5, and we traverse it from right to left. First 5 will come to queue, then 4 will come. Okay, now check there are queue is full or not. Queue is full, so we'll first remove 5 from queue and go to stack. Remove 5 and it will go to stack. Okay, it will also be now root. Now check 5 have any children, no, so no need to enter any nodes into queue. Now move forward, and now root node is 4. Root node is 4, and our queue is also full, so we will push it to stack, and we will push it to stack. Now 4 have any children, no, so no need to enter any nodes to queue. And now in stack we can see all of nodes come from here. This binary all nodes come this stack. Now we need to print the all of nodes which are come last. We will remove it first. Okay, it means 4 come last. So we will print first we'll remove 4. Okay, change the color, remove 4, then remove 5, then remove 2, print 2, remove or print what you say, then print 3, then 1. It will be last in first out. We also say last in first out, and q is first in first out FIFO. Okay, now in this I also say in reverse it will be like this. You can say in stack first 4 will come, and 4 will come, then 5 will come. You can check 5 will come, then 2, 2, then 3, and 3, then 2, then 2. Sorry, it will be 1. I missed it. It will be 1, then 1. Okay, can make. Now go to code. In code, first what we have to do, we define function. Okay, we define function def reverse level order. Then we check the root is empty or not. Okay, you check the tree empty or not. If the tree is empty, then it returns an empty list. It returns empty list, and as there are no nodes to process. And then next 3 lines we initialize the result queue and stack. And result is store final result. If so, reverse level order traversal of the tree, and queue will dequeue. Dequeue means double ended queue, which remove and enter the node. Okay, and it will also for level order traversal BFS. And stack is used to reverse the traversal order after BFS for this. And now we enqueue, the root. The root node is enqueued to start the BFS traversal. Then we go to BFS traversal, this program, this 4 5 lines. And while loops will run until the queue is empty. While loops will run until the queue is empty. And node will decode means it popped from left from the queue. And data node and node data, and this node data is append to the stack. This build a stack with nodes in level order but in a reverse manner. Okay, now this condition, if is decode node has a right child, it's enqueued. And this if condition decode node has left child, it's enqueued. Okay, now we reverse the traversal order. This while condition stack while stack return append, and this loop pops element from the stack, and it appends them to result. Then it reverse the order to get reverse order traversal. And last line is for return the result, and this function will reverse level order traversal of the tree as a list. Okay, now compile and run. Okay, now submit it. Okay, it's done. Solve today's solver. See you in next video. Stay tuned. Bye bye.